so half of our market was dead. And then mid-2000s, we had panel shortage. We had projects, but we didn't have panels because Germany pretty much was taking, with their stronger euro, was taking all the panels. So we couldn't install for almost 4 years. I mean, we were installing maybe a quarter of what we could have installed. And then the latest is this financial situation, and equities in the properties have disappeared, so a lot of financing has disappeared. Businesses are not very stable, so banks are not lending. So pretty much solar has become a more cash-based business, but it has very good incentives when it's cash. We have some of these, couple of the proposals here. This is a house we did recently. It's about 14 kilowatts. After converting to AC, it's about 13 kilowatts. It's even less. This is official version of it. Daily it provides 57 kilowatt hour. It's about 80% of the homeowner's need. About 1,200 square feet it requires. We are going to be using 78 panels of Mitsubishi 185 watt with 3 inverters of 5,000 SMA, German made. And monitoring system and DC disconnect, AC disconnect, and a bunch of other things. Total price about $85,000. SCE rebate, which is usually lower than DWP or other utility companies, is 23,000 of it. This is actually lower now. It's about $10,000 now. By the way, rebates keep on dropping. I don't know if we were told about it, so one of the rushes I would say in the solar is to apply soon because rebates are dropping. SC stopped the rebates for about a month, now they started again. Glendale just stopped it for a whole year. So rebates are not that stable. So customers, we usually carry the rebate for the customer. Customer comes up out of pocket $62,000. They get paid. This is residential, they get paid 30% of it in tax credit. This is not tax reductions, this is tax credit. I mean, it's not tax...
tax credit.
It's tax credit, it's not the other one. So it reduces their total cost to $43,000 from $85,000. In 25 years, estimated savings is about $14,000. According to Wells Fargo, it's going to increase the property value about $98,000. And it's about, return on investment is about 17%. So in general, it does make a good business sense to do solar. If they did do solar with all the costs and everything in 25 years, the average kilowatt hour cost is going to be about 10 cents per kilowatt hour. If they did not do solar, it's going to be about 69 cents, according to the past 30-year price increases. And other things like the property tax doesn't go up. There's the incentive to do solar, since the property value went up by $98,000, but the property taxes do not go up. And it helps the environment in many ways. Pounds of carbon dioxide, nitrous dioxide, carbon, anyway, from different things. And it's about 13 acres of trees that it's going to produce the same amount of clean air that this project will produce. If I compare that to a commercial project, which is not a big size, we did this last year, mid-2009, about a year ago, yeah. 54 kilowatt. The big project now we got is about 1,500 kilowatt, 1.5 megawatt, so this is nothing compared to that. Go to the costs, is about $300,000 cost, but the rebate in LADWP is almost half of it. It's about $144,000, so about half of that comes out from the rebate, and $144,000 is left for the customer. and we carry the rebate. So customer pays $144,000, tax credit 30% comes out, and additional for commercial there is 5-year maker's depreciation, which is bigger than that 30% comes up in 5 years. So the end cost is $46,000. That's not including the savings in the energy. Property value goes up about $130,000. Return on investment, internal rate of return, 24%. With these, we usually provide additional explanations. Comparing PV to stock market or to the banks, this is even lower now. It's almost zero. PV's rate of return is much higher. Here we're showing different times of the months, how April and May are the best months to produce solar. It produces the most compared to the December or January. Savings in 10 years about 100,000. This is electricity savings, electricity bill. In 20 years about 300,000. In 30 years about $750,000. And this kind of shows that graph that it's in about 5 years it breaks even, goes up. We expect the inverter to go bad in about 15-20 years. So that's why we are showing a replacement cost here, but pretty much there's no other costs. And then it goes, so from this investment, it goes to this investment. 25 years warranty time, because the solar panels are warranted for 25 years. And this is kind of a little bit cost breakdown of different things. Year one, $289,000 is reduced by the rebate, by the tax credit, federal depreciation, state depreciation, electricity generated, and this is electrical kilowatt hour, and this is electric in demand, which is different animal. It's measured in kilowatt. So within the first 5 years, they're still in negative. 6th year, they're making positive, and until 25th year, they're making about $500,000. Different steps of it. There is a trick also. The company we are going to do the project, they're going to recover their cost in 1.5 years. And one of the tricks they're doing is that they're considering rebate as income, ordinary income. So they pay their taxes on that ordinary income, but the tax base for the federal tax credit and depreciations are not reduced by that rebate amount. And suddenly they're saving, I don't know, about 15% more in the total cost. So 1.5 years they're recovering their cost. Pretty much I'm done.